right. Welcome back, everybody, for another deep dive.
Yeah.
Today, we're going to be looking at something that sounds a little bit technical, maybe even a little dry.
Okay.
But trust me on this one. This is some really fascinating stuff, and it applies to, like, pretty much every part of life. We're going to be talking about mathematical inequalities.
Oh, cool. Inequalities, yeah.
Inequalities, yeah. Now, you might remember those from back in high school,
Right.
greater than, less than, all that.
All that stuff.
But we're going to go a little deeper than that.
Nice.
We're going to be looking at solving and graphing one-step inequalities, multi-step inequalities,
Wow.
compound inequalities,
Oh, boy.
and even absolute value equations and inequalities.
I love it.
So we've got a lot to cover today, and I think it's going to be pretty eye-opening.
Yeah, I think it will be, too. And I'm really excited to break it all down in a way that, anybody can understand.
Exactly. You don't have to be a math whiz to follow along.
Nope.
So let's jump right in. I think maybe the best place to start is with those one-step inequalities, right?
Yeah, absolutely.
Kind of like lay the
Let's
foundation.
lay the groundwork.
Yeah, exactly.
So one-step inequalities, at their core, they're pretty simple, right? We're talking about using addition, subtraction, multiplication, or division to solve for a variable.
Right. Pretty straightforward.
But it's not just about getting to an answer.
Right.
It's about understanding what that answer means in the real world, right? Like how it applies.
Yeah. Yeah. Give me an example of that.
Okay, sure. So think about it this way. Let's say you're saving up for, a new phone, right?
Okay.
You know how much the phone costs, and you know how much you can save each week.
Uh-huh.
So you can set up a one-step inequality to figure out how many weeks you need to save to reach your goal.
Right.
So the number of weeks times the amount you save each week has to be greater than or equal to the cost of the phone, right?
Yeah, that makes sense.
And then you solve for the number of weeks, and boom, you know how long you need to save.
Perfect. Right. So it's not just like an abstract thing. It's
Oh,
like
not at all.
you can actually use it.
It's practical.
Yeah, it's practical.
Very practical.
That's awesome. Now, our source material also talks about graphing these one-step inequalities.
Right.
What's the point of that? Like, why do we need to visualize them on a number line?
Well, it's all about understanding that range of possible solutions.
Okay.
Because with an inequality, it's not just one answer. It's a whole set of numbers that could work.
Yeah, yeah.
So by graphing it, you can see that range. You can see all the numbers that satisfy the inequality.
And how does that, like, translate to, the real world?
Oh, it's used all the time, especially when we're talking about data, right?
Okay.
Think about, economists, they use graphs all the time to show things like, income distribution.
Yeah.
They might graph, all the households earning more than a certain income.
Okay.
And that graph will show you how that income is spread out, who's making what. Right.
And that's all based on inequalities.
So it's like a way to visually represent those inequalities.
Exactly.
That's really interesting. Okay, so we've covered the basics of one-step inequalities.
We got those down.
But our source material takes us a little further. Right?
Of course, yeah.
It talks about multi-step inequalities, which, I'm not going to lie, sound a little intimidating.
Yeah, multi-step, they sound scarier than they are.
Right.
Really, it's just building on what we've already learned.
Okay.
You're still using those basic operations. Addition, subtraction, multiplication, division.
Mm-hmm.
But now you might have to do a few of them in a row.
Right.
To isolate that variable.
Okay, so it's like a puzzle.
Kinda, yeah. It's a little puzzle, but the key is to remember the order of operations,
PEMDAS.
Exactly, PEMDAS. You got to do things in the right order.
Right.
And yeah, you got to be really careful with that inequality sign.
Oh, yeah. Especially when you're multiplying or dividing by a negative number.
Right. You got to flip that sign, remember? Yeah, I remember that from back in the day.
Classic mistake.
Yeah, I made that mistake a few times.
We all have.
But it's interesting. It's not just like a random rule.
Right.
It actually makes sense when you think about it.
Oh, yeah.
Like if you're comparing two things and one of them is decreasing
right,
and you multiply by a negative number, it's like you're flipping the whole comparison around.
You're changing the perspective.
Yeah, exactly. So it's not just like a math trick. It's like a logical thing.
It's a reflection of the real world.
Yeah, that's cool. So multi-step inequalities, not as scary as they sound.
Not at all, once you get the hang of it.
Okay, good to know. But the source material doesn't stop there, does it?
Oh, no, it keeps going.
It throws in compound inequalities.
Compound inequalities, yeah.
Which I don't even know what to picture in my head.
I know, it sounds like a mouthful, right?
Yeah.
Compound inequalities, they're basically when you have multiple inequalities happening at the same time, You're basically combining two or more inequalities, often using words like and or.
Okay, so give me a real-world example of that, because I'm having trouble wrapping my head around it.
Sure. Imagine an engineer designing a bridge, right?
Okay.
They need to make sure the bridge can handle a certain amount of weight, but also not too much weight.
Right.
So they would use a compound inequality to set those limits, those boundaries.
Okay.
So it would be something like the weight on the bridge must be greater than X, but
Okay.
less than Y.
Right.
So it's defining a safe range.
So it's like it has to be within those parameters.
Exactly. It has to fall within a specific range.
That's really cool. So it's not just about finding one answer. It's about setting those
So
boundaries.
it's about defining the acceptable range.
Yeah, and making sure everything stays within those boundaries.
Precisely.
That's fascinating. Okay, so we've covered one-step, multi-step, compound.
We're on a roll.
But we can't forget about the big one.
A big kahuna.
Yeah, absolute value equations and inequalities.
Yes.
These always kind of trip me up back in the day.
I get it. They can be a little tricky.
Yeah.
But really, it all boils down to distance.
Distance.
Yeah. Absolute value, it just tells you how far a number is from 0.
Okay.
Like the absolute value of 5 and the absolute value of mesa 5 are both 5.
Right, right.
Because they're both 5 units away from 0.
Okay, I remember that.
Now, with inequalities, it gets a little more interesting.
How so?
Because now you're not just looking for one distance. You're looking for a range of distances. So it's like saying, I need something that's within 5 units of this target.
Right.
But it could be 5 units above the target or 5 units below.
Oh, I see.
So you have to consider both possibilities.
So it's like it doubles the complexity in a way.
In a way, yeah.
Because you have to look at both sides.
Both sides of the target. Exactly.
And how does that apply to like real world situations?
Oh, all the time. Like, think about manufacturing, right? When you're making parts, they need to be a certain size, but there's always a little bit of wiggle room.
Right.
Like they can be a little bit bigger or a little bit smaller.
Right.
And that's where absolute value inequalities come in.
Oh, okay.
You can use them to define those acceptable tolerances.
So it's like setting the boundaries for like...
Exactly. For
Yeah.
how much variation is allowed.
That's so cool. So it's not just about hitting the target exactly. It's about understanding.
It's about understanding that there's a range of acceptable values.
Yeah, those margins of error.
Or margins of error, exactly.
That's amazing. Man, we've covered a lot today.
We've been through the whole spectrum of inequalities.
From those basic one-step ones all the way to absolute value.
And you know what I think is really cool is how these concepts, they're not just like math problems.
Right.
They're tools for understanding the world around us.
Yeah. I never thought about it that way.
It's about thinking in terms of ranges and possibilities, you know? Like whether you're setting a budget, designing a bridge, or even just figuring out how much pizza to order.
Right.
Inequalities help you define those boundaries and explore the solutions within them.
It's like it gives you a framework for thinking about problems.
Exactly. It helps you break down complex situations.
Yeah, and make informed decisions.
Absolutely.
This has been really eye-opening. I'm going to be honest, I was a little intimidated by this topic at first.
I understand.
But now I see how practical it is and how it applies to so many things.
Yeah, it's all around us.
Yeah, it really is. So, to everyone listening, next time you're faced with a problem, big or small,
Yeah.
take a moment to think about how inequalities might help you frame it.
Think about those ranges, those possibilities.
Yeah, you might be surprised by what you discover.
Absolutely.
All right, that's all the time we have for today's deep dive.
This was a good one.
But until next time, keep diving deep.
Keep exploring.
We'll see you then.
See you next time.